Hi everybody, sorry I couldn't be there today. We're going to do a little video for today's webwork problems, and a word of warning, please watch the video because there's a lot of weirdness in how you have to answer some of these questions. There are a lot of state of Idaho problems, and you know how I feel about that. So let's take a look. Problem 1, here we go. Perform the indicated operation. We're going to combine these two rational expressions into one. In order to do that, we are going to find a common denominator, which means multiplying the first rational expression by y minus 1 over y minus 1, and the second rational expression by y minus 5 over y minus 5. That gives us a common denominator, and we can combine the two expressions into one. What we're left with on the top of this first expression is a 5 times y minus 1, and on the second expression, a 3 times a y minus 5. Then, as the last order of business, we want to distribute these two terms in the numerator out and combine like terms. Here I've multiplied everything out, and here I've combined like terms. Now, if we were lucky, what would happen is we might be able to factor this numerator that was left, and maybe even cancel something with that numerator in the denominator. But we can't do that. Here's your webwork warning. For all tests, this answer would be perfectly fine. This is the one that we want. If you can factor the numerator, great, do it. But this is the answer that we want. These Idaho problems in webwork don't like this. What you actually have to do is you have to FOIL out the denominator. So you have a polynomial in the numerator and a polynomial in the denominator, and that's the answer that it wants. So if you do that and combine your like terms, you get that answer, and that is what webwork wants. Another warning. Make sure that you put parentheses around your numerator and your denominator. That way, webwork knows that this whole thing is the whole numerator and that this whole thing is the entire denominator. Okay, next problem. All right, here's the next problem. We are going to multiply and simplify. And in this example, that means factor. We're going to factor everything first. Fortunately, you all are factoring experts at this point. You have a couple of differences of squares that you'll recognize, and these are just regular trinomials. Now, when you get to this point, a lot of things can cancel. Since everything is multiplied in the numerator and everything is multiplied in the denominator, you just have factors, and you can cancel any factor in the numerator with the same factor in the denominator. So for example, those two x plus 1s will cancel. These two x minus 5s will cancel. And we get a pretty simple few binomials. We get a couple in the numerator and a couple in the denominator. Again, that is the answer that is acceptable on your test, say, for example, and on any of your quizzes. That's the answer I want. However, these are College of Idaho problems again, and they're going to require that you FOIL out both the numerator and the denominator before you enter your answer. So that is your answer on a test or a quiz. This is your answer in webwork. Again, don't forget to put your parentheses around your numerator and your denominator so the webwork knows what you're entering. Okay, let's take a look at problem 3. Problem 3 happens to be very similar to problem 2, so I will let you do that. How about problem 4? Again, just one more problem, exactly like it, just with different numbers. Let's move on to problem 5. Problem 5 is a complex rational expression. You notice that there are rational expressions within this bigger rational expression. We're going to simplify it as best we can down to just a numerator and a denominator, and we're going to enter the numerator here and the denominator here. There are going to be a couple of different ways to do this. What I'm going to do in this video is I'm going to find a common denominator in what I'll call the top here. I'm multiplying this first term by x over x. I'm also going to find a common denominator in the bottom by multiplying this term here, just that term, by y over y. What that's going to do is leave us with a 5x over x squared, this term right here. And I'm just going to copy down the 5 over x squared there. In the bottom, we're going to be left with a 6y over y squared and an 11 over y squared. Now, you can combine the two terms in the top and combine the two terms in the bottom. Great. Now, what we've got this problem down to is two fractions. It's a complex fraction. You know how to divide those two things. You copy the top one down, you multiply, and you flip over the one in the bottom. There's really not much to simplify here. I'm just going to write this as y squared times the quantity 5x plus 5 on the top, and x squared times the quantity 6y plus 11 on the bottom. Okay, and I entered that into webwork and I edited it out so that you wouldn't have to see me struggle with it. Y squared times 5x plus 5 in the numerator, x squared times the quantity 6y plus 11 in the denominator. I'm going to check that just to make sure. Good, webwork likes it. Okay, let's move on to the next problem. Now, I believe you've seen a problem just like this, I believe on Monday, or Tuesday, sorry. So I'm going to let you do that one on your own again. And we're going to do this tricky looking thing right here. Now, this is just a silly problem to see what we can do with these rational expressions. Let's take a look. Now, if we look at this problem, there are actually a lot of sort of hidden parentheses here. And our order of operations tell us to start with the innermost parentheses. So I'm going to start by simplifying this piece right in here. How do I combine 1 plus 1 over x? Well, the way that I do that is I multiply the 1 times x over x so that I have a common denominator. Now, it's going to be a bit of a challenge, but I'm going to copy this down the same way every single time so I don't lose anything. Okay, and this time I just changed that 1 into an x over x. I did that so that now I can combine these two terms with the common denominator. If you copy the problem down every single time, you'll be less likely to lose anything. Here we have a complex fraction. We have 1 over 1 divided by x plus 1 over x. What we do with that is we copy dot flip. We copy the top fraction down and we flip over the bottom fraction, which is this right here. And since we just have a 1 over 1 here, we don't really need to write that. We can actually just erase that 1 over 1 if we'd like, or I'll just copy the problem again without writing the 1 over 1. Now the task that we're faced with is combining these two terms right here. And if we're going to do that, we need to multiply this 1 by x plus 1 over x plus 1. That way we get a common denominator just in this little piece right here. So I'm going to copy all that down. We've now replaced this 1 here with an x plus 1 over x plus 1. And we're going to keep going here. We can combine these two fractions right here because there's a common denominator now. If we do that, we add the numerators, x plus 1 plus x. The two x's add up to 2x, and we're left with the plus 1 here. The denominator stays x plus 1. Now again, we have a complex fraction. We have in the top, we have a 1 over 1, and in the bottom, we have this mess. So we're going to copy dot flip that thing again. And since we have this 1 over 1 here, we don't really need that. We can copy the problem down without it. And we are down to our last order of business, which is just combining the two terms that are left. The only way to do that is with a common denominator. So I'm going to multiply this by 2x plus 1 over 2x plus 1. And now we have the common denominator that we need. The first term here becomes 2x plus 1 over 2x plus 1. The second term is still x plus 1 over 2x plus 1. And we can combine these two. The numerator is going to be 2x plus 1 plus x plus 1. 2x plus x is going to give us a 3x. The 1 plus the 1 is going to give us a 2. And our denominator stays the same, and that should be the answer. I edited out me typing that in, but when I did, the numerator here, denominator here, webwork liked it. So we're going to go to the last problem, which is another one, just like one of the previous problems we did. You're going to find a common denominator up in the top, find a common denominator down here in the bottom. You're going to do the whole copy dot flip thing, and good luck. I will see you all on Monday.